welcome. I'm going to formally get started. We have a fantastic panel this afternoon. Like I said, I am Alejandro Poiré. I'm a political scientist by training. I'm the Dean of the School of Social Sciences and Government. And we have a fantastic panel today with Alejandro Diaz-Dominguez, a professor and researcher at the School of Government and Public Transformation here in Monterrey. Francisco Cantú, a political scientist at the University of Houston, and Michelle Torres, a political scientist at Rice University, and Stephen Popper, who is, one of the founders of DMDU. He's at Rand Corporation at the Pardee Rand School of Public Policy. And the panel today is entitled Approaches for Integrating DMDU into Political Science. And what I will offer here is this old image of a Spanish-written translation of this classic by David Easton, Framework for Political Analysis. And so that's the book cover and the main image diagram, it's called, of Simplified Model of a Political System. And I want to remind you of this image because what I hope that we may have a conversation about is the fact that when we talk and we think about DMDU methods, we typically think about policy challenges that are very complex in nature, very uncertain, with overlapping levels and structures of uncertainty to be addressed, that regularly have to do with not just individuals and firms' decision-making, but with policy decisions that have to be engaged. And on the other hand, what this scheme that I showed you illustrates, I hope fairly clearly, is that, and I'll just share it again very briefly, is that these policy decisions that are on the right side of this crazy black box that we learned from the 60s are actually done in an environment that gets feedback into the supports and demands, the inputs of the political system as they may be. And in a sense, when we think about political processes, we are thinking about preference aggregation. There are questions about how we aggregate preferences that will have an impact on what kinds of policy decisions we may or may not be able to come up with. Many of the challenges that we're worried about, energy, decarbonization, sustainability, water, food, all of these issues that are near and dear to our hearts at the DMDU society are made more or less likely to have a positive outcome or even a coherent outcome depending on the politics that they live in. But they also live in that political system, but they generate feedback into the political system. So I'm hoping that today we will talk a little bit about that, and that by integrating these methods, we may have a better sense of whether, for example, the world that we live in today, this world of political polarization, very limited consensus, very limited ability to use evidence-based methods for a lot of areas of policymaking, especially at the national level, is probably a low probability scenario or is a central probability scenario, and whether we can do anything in terms of recommendations for political reform, political discourse and narratives, in terms of improving the likelihood that we will live in a scenario in which the kind of politics that we live in is more conducive to the kinds of policy research and decisions that we're also peddling on policymakers, analysts, and all sorts of stakeholders in the world. So those were my 4 minutes of introduction. We have, like I said, 3 great presentations. I am going to give the word now to Professor Alejandro Diaz-Dominguez, whose presentation is entitled Deep Uncertainty in a Post-COVID Polling World. Alejandro, you have the floor for about 12 minutes.
Thank you so much, Alejandro. Nice to see everyone. Thank you so much for this opportunity to share some thoughts about the polling world under uncertainty, but in the middle of the COVID pandemic that we live now. We have this discussion about polls accuracy. We usually use the Mosteller tree, which is the average error for the surveys. And typically this measure, the Mosteller tree, is explained by the typical stuff such as sample size, margin of error, days before the election, etc. And mode effects, of course. Mode effects are the ways in which we collect data, such as robopolls or live phone polls or line web surveys or a mixed method, right? So we have this in the literature and we are analyzing this through the years. I want to use the example of Florida. This the last election that we have. Let me to try to a bigger screen, and I'm using this collection of surveys by 538, and then we have these at least four modes, which are the live phones, the mixed methods, the online, and other modes. And we see that the blue line is the Biden-Harris percentage, the 48% pretty much that they won in Florida. And we see that this some variance here, right? I mean, depending on the mode, we have more variance. So it's a difficult picture because it's not clear whether Biden and Harris will get the 48%, right? This is challenging. So in this world, we have to back to the basics, in which some polls perform better than others. Yes, of course. What about predictions? What about aggregation, polls of polls? Well, if we have this combination between bad and good polls, maybe we fail in our forecast, maybe not. So pollings are like, polls are always under uncertainty. So perhaps it's a nature, perhaps it's that. So we have this Mosteller tree by Alejandro Moreno, is bolstered by the newspaper El Financiero. And we see this is in Spanish or other, but pretty much we have the Florida here with the average. He's using not the 538, he's using the Real Clear Politics collection of sample surveys. And we see this average here, 48 for Biden, and the result was pretty much that result, and the M3 is 2.2. So seems like these surveys were not exactly bad. But what about aggregations? In aggregations, we see this Florida prediction by 538 by Nate Silver, and we see 49.1 for Biden. So that's one of the case. What happened? If we run a very simple Arima model, the typical time series example, using the whole collection of the 538 surveys, we got the 47.8 estimation here. So that's very clear that the Nate Silver model was slightly off for 1 point, but he's very sophisticated, right? So what happened? With very simple Arima, we can get pretty much the right result. So we need to explore what happened with polls in this situation. So one way to evaluate this is using algorithm, right? So I'm using at least two, the R part, which is a very simple decision tree, considering all the typical variables that we use when we are trying to evaluate surveys. And a second algorithm that I'm using this day is the PRIM. It's a classification, just a classification. A cautionary note is just a very simple and preliminary example. It's pretty much work in progress. So it's just the very initial effort, okay? So forgive me if it's not perfect, of course. For the classification, for the decision tree, sorry, we have these considerations, right? If we have very small samples, Biden Harris, they receive 47. If we have larger samples, but they are not very far away in time, we have 49. if we have some samples or some surveys close to the election day, we are getting 49, 49, 49, 48 actually. So it's very clear that depending on the time and the sample size and whether or not your model includes likely voters or not, it's very easy to see in this decision tree that we have some characteristics that are important for surveys. So that's a typical decision tree, just using the 210 surveys that we have in the Florida case. Now, using the PRIM, the Paschen rule induction method, we use binary variables, just cutting the data in binary variables. We have two main statistics here, which are density and coverage. We have coverage, which is essentially whether one variable is important considering all the universe that we are studying. And density is when one variable is important just for this specific cluster in which the algorithm is working on. And there is a trade-off, of course, between density and coverage, because when we have more coverage, we have less density. And we can see these in these peeling trajectory curves. I already explained or tried to explain this. Sorry, I'm trying to keep myself in the 12 minutes. So in the peeling trajectory, the very first model is the initial model. We see, or we're used to see in this type of diagrams or pictures, we're used to see a lot of little points here, right? Well, I only got two. The first one is the mixed methods surveys. So it's a combination between mode effects. So you have, your survey is divided by web, and the other part is online, live phones or whatever. No, you have a mixed method in your survey. And the second one is the likely voters. It's important because versus random voters, right? It's important because in the likely voters model, we want to incorporate these citizens who are voting by mail. In this election was an important factor. So likely voters is still important to estimate these and offer your results based on likely voters. So we have some coverage here. We have more density, which suggests that we are better within the cluster. So if we run several models, just the initial model and a model with more variables, we still have like a 2 dimensions or 2 boxes. And in the first one, in the very initial, we have the mixed methods surveys. They have, well, a decent coverage, not much, to be honest with you, but they have good density, actually the likely voters as well. So when we incorporate more variables, we have, of course, a very good density here, using this time frame before and after the 4 months, but the coverage is very small. So this very initial model, I have to improve the model. So, but this is the very first attempt that I have. And when you use more variables, more effects, sample size, and so on and so forth, we see pretty much the numbers that I showed you in the prior slide. We have not much coverage here, but we have some density here. So that's a trade-off, right? So in sum, just the preliminary conclusions here is, well, we still need the Mosteller tree and all the public opinion stuff that we know, but with some classification algorithms, we have the chance to explore what type of adjustments we need in order to have better estimations. According to this very preliminary evidence, COVID was not the main factor here, is not responsible for whether or not polls were better or worse, is because when I use the full sample, the full universe of surveys available, we don't see that it's impossible to predict the right result. So, and when I use just 4 months, we can get the right numbers as well. So we have variability in the polls, but overall, they are not so bad. But of course, there is always room for improvement. Mode effects are important, the way in which we collect numbers of data. And of course, I have more homework to do. I have to clean the fielding days. I have to add margin of errors because for my surprise, some aggregations, they don't include margin of errors in their data sets. And of course, I need to include more variables in order to increase coverage. And thanks so much for your time and your passion.
Thank you very much, Alejandro. This has been a really sophisticated and quite to the point evaluation of what went wrong in the polling world in the most recent presidential contest. Next, we turn to Stephen Popper, with what he announced would be a speculative meditation on the politics of endpoints, or between Werner Heisenberg and Annie Oakley, shooting at moving targets. Thank you very much, Stephen. The floor is yours for 12 minutes.
Thank you very much, Alejandro. I'm going to talk a little bit about how this strange name came about, which I actually started thinking about in terms of COVID-19. And then I'm going to swerve away from the kind of the speculative and actually talk about some actual work to illustrate some points. So if we're talking about the title of the session is Approaches for Integrating DMDU into Political Science, we're probably not thinking about poli-sci, in its forensic role. Why did this election turn out? I'm not saying that that's not the case, but we are probably speaking more in a prospective sense of political science, more the science of politics, the science of policy. So I will talk a little bit about the interplay between the policy process and policy goals. Then I'm going to go to an example which, by very happy chance, addresses precisely Dean Poiret's point about preference aggregation and how we deal with that. And then get very speculative by talking about some work I did recently that might have some resonance for the political scientists. I'm an economist, so I'm here by sufferance. So this is how we usually think of ourselves as we look at the policy process and how we conduct ourselves. This is probably true for the Abraham Lincolns and the Otto von Bismarcks and the Franklin Delano Roosevelts of this world, shooting at moving targets from a moving platform. But we act in our policy institutions and processes as if we can knowably determine what policy is, set a policy course, and then let the future unfold. If we look at the case of COVID-19, I started taking exception with my RAND colleagues back in February when they spoke of recovery from COVID-19. I didn't think that was quite the right word. If we think about a natural disaster, we can proceed on the assumption that we're all talking about, how we are going to recover, how we're going to put things back together, how we're going to put a downtown area back in commission. But with what we're going through now, nobody knows what the new normal is going to be. And the interesting thing for us is that we can do things in order to fight COVID-19 on the short term. Close schools, limit restaurants, and so on and so forth. But these in themselves will have indirect consequences for the longer term. So we really have the problem of thinking about our different strategies and timing in order to achieve our short-term goals, but have cognizance of how they may transform long-term goals, not only the perceptions of what might be desirable, but also the very nature of what is attainable. And what I'm suggesting is it's a little more like this. For those of you who have forgotten what you learned in quantum physics, the idea that a particle operating under quantum conditions, you can determine either its location or its velocity, but you can't do both because the very act of observation actually changes the nature of the phenomena. So what I'd like to do is to actually show a demonstration, an initial demonstration kind of moving along these lines. And this is harking back to work that Rob Lempert and I co-led on the problem of policy persistence. So the idea that that policymakers are assumed to have a window of opportunity to pass, in this case, climate legislation, which then institutionalize a framework, but they can't bind the hands of future lawmakers. So subsequent to the initial passage, in this case, the price of carbon is allowed to fluctuate and is influenced by the best estimate of the socially optimal price and the relative strengths of various industry stakeholders. So this is an agent-based model. So now we're talking about individual preference. And to my knowledge, I think this is the first model I've seen of an agent-based model variety that has the economic system, the system bringing forth technological innovation, and the system of political process in the form of a lobby. Actually, several lobbies form, 2 or 3 different lobbies form, and based upon government preferences and the strength of the various lobbying groups, a carbon tax is set, as are other government regulatory processes. So it looks a bit like this. Each line here is an individual firm proceeding over time. The color indicates what their preference is for the price of carbon as their market share changes, as other variables affecting them change, and so their preference change. And this then shows the net result. In red, we have the price of the final good. Black is some socially determined cost of carbon, and then the actual tax, the actual pricing is determined through this lobbying. So the point is really brought home by this next slide, where the preferences for the policy, the original setters of the policy, are looking both for high rates of decarbonization and high rates of what's called here the labor intensity improvement rate. It's really a proxy measure of indicating trade-offs between carbon reductions and other societal goals. The 16 boxes are different combinations of government welfare preferences as they proceed through time, the extent to which they are seeking low emissions or would allow for high emissions, low government revenue proceeding from a tax, high revenue, low price fluctuation versus a willingness to accept higher price instability, low production loss versus high production loss, which is kind of a proxy for employment. And so what this allows you to do is to observe the net behavior of different policies. These are the different policies here along the bottom line, how they would behave in net over time. And this is the way that one can begin to think about how do you actually design the policy in such a way that it can operate in the political sphere, that it can be robust to various uncertainties, and have a reasonable chance of meeting the original goals of the policy designers. Obviously, this is very quick. You'll find the reference there. You can follow up on the paper. Now I'm going to go to a next question that arises in political science, which is, it's a lot more complicated. The system is more complex than it is in physics, or the way economists like to pretend that it is. So how do we use DMDU if we don't really have formal models? We don't have, big involved equilibrium models of geopolitics. And the answer is, well, maybe it depends on how we frame the questions we're asking. And this is work that I've talked about previously, but not in this context. I bring it up again because I think it has relevance for DMDU and political science. And I'm still looking for somebody to tell me this is really a bad idea, Stephen. And here's the reason why. So let me put it out here. You don't have a model, but what you do is go through an elicitation process where you force people to make causal statements. In this case, there's a particular outcome we're interested in. This was work done on security cooperation activities by the US military. There are a number of different activities that they engage in. We make an assessment, we elicit a causal statement about what the relationship is between this activity and this desirable outcome. And in this case, we're looking at the scale. And in the next, we are looking at the functional form. So we get some idea of, a causal statement about what we presume the relationship is in terms of how much the effect is, and whether it's a constant returns to scale, decreasing returns to scale, sigmoid, and so on and so forth. So have I just made this up? There is no model? Well, the question is, what's a model? It's a formalized mathematical statement of relationships, sure, but it's also, a theory of causality in the development literature, a theory of change, or political science literature. And I would submit that plans are made today on the basis of tacit theories of change. Two political scientists will look at the same literature and the same data and draw different conclusions. And these theories of change are implicit. They motivate decisions, but they're difficult to share. They're not articulated, and they're not directly connected to evaluation or subject to scientific investigation. So they exist. And so in this procedure, I'm suggesting you elicit and specify them, and then look at the implications. So if we're looking at a number of different potential portfolios or programs of action, how well might they do? Well, you specify these causal relationships. Each point here, each of these 6 points is something you care about. This is basically how good it is. The black line is, the current program, and now you do a search through solution space for potential improvements, including this one in red. And then you can begin to ask questions. Well, what are the differences in theory of change implied by these alternatives? And in this case, the current plan implies a lot of emphasis on education. This one implies a lot of implications on exchange activities. What if we were to change these causal statements to a different set of them? How does that affect outcomes? And here you see, a change in outcomes. Well, okay, so if these different causal statements, different assumptions about causation have these effects, what would, our choices look like under this new theory of change? It looks something like this, which can be explored. What are the assumptions that might cause us to prefer one or the other? What are the conditions that stress or support each alternative? And now, similar to the work that Alejandro spoke of just before me, you can begin to do things like, run prim, do scenario discovery, so on and so forth. So I think what this does, again, I'm waiting for somebody to tell me why this is not so, but I think what this does is it makes underlying assumptions explicit, provides a framework for systematic discussion about assumptions. It addresses uncertainty explicitly, helps us discover important new scenarios analytically and potential and new courses of action, to incorporate evaluative insights, the forensic aspects of political science, feed that back into the definition of the causation, and conduct an analysis in the absence of an explicit model, where in fact the model is itself in part an output of the analysis. So this is, as I say, this is potentially a way to provide an ability to frame and test complicated causal arguments, in a word, policy science. And I thank you for your patience, and I apologize if I went over my time.
No, you're right on time. Thank you very much, Stephen. That was a great, very thought-provoking presentation. We now turn to Francisco Cantu and Michelle Torres. They will have a presentation on using causal neural networks convolutional neural networks, to record voting results. This is particularly pertinent these days, as there are still races yet to be called and votes yet to be counted. Go ahead, guys. You have the floor for 12 minutes.
Well, thank you very much. We are super honored with the opportunity to share our work, and thanks to Edmundo and Alejandro for organizing such a great event. So the idea here, in 12 minutes, what we want to do is to present or to introduce the concept of convolutional neural networks to social scientists, right? So it's going to be like a very brief introduction on how convolutional neural networks work, and also we want to show you how we are applying this methodology to the problem of counting vote returns on election night. So this is, I'm sure I don't have to spend too much time on this slide, because the audience is expert on this. But just as a reminder, what will be the advantages and disadvantages of using computers over humans when we have a tedious and labor-intensive task, right? Because of course, computers are faster and more reliable. They don't get tired, they don't complain, they don't have cognitive biases. But until a few years ago, they were unable to solve unstructured problems, right? They were unable to learn from experience. And that's when, I guess the new generation of computer scientists came with this, artificial intelligence. So, and one of these products is a convolutional neural network, which is just a learning algorithm to analyze and classify visual information. It can analyze other type of inputs, but at least in this case, we're going to focus on visual information. What it does is that it decomposes the image into multiple components, and then it's going to assign importance or weights to each of these components in order to predict the label of the image, right? Or to what category does this image belongs to. And emulating how the human brain works, these CNNs are organized into multiple layers. Each of these layers will have different neurons, and each of these neurons is going to look for a specific feature of the image. This is just an example of the structure or the architecture of the neural network. And there are like two main functions, feature extraction and classification, right? What it's going to do first is to transform the image into a numerical array, where each number within the array represents a specific pixel value. So in this case, we have the image of the number 1, but as any other digital image, what that picture represents is just a collection of pixel values, right? So we're transforming the image into this numerical array. And then I guess the common pixel range goes from 0 to 256. Here we are just collapsing that range just from 0 to 1. So again, this is how we transforming the image. And then this numerical array is going to be the input for our first convolutional layer, which is going to be a collection of different neurons or filters. And each of these neurons or filters are going to pass, or is going to pass through the input image, and is going to compute the dot product between the filter and the input matrix, right? In this case, for example, this filter represents a diagonal that starts from the upper left corner. Another examples of basic filters could be, I don't know, a vertical line or a horizontal line. The idea is that this filter is going to pass through the input matrix. It's going to compute the dot product all over the image. And the results of these dot products are going to be a feature map. So this kind of, you know, what is the overlap between the specific feature and the input matrix, right? Now, just to, you know, we're going to have multiple neurons, again, with different, that are going to represent specific features. So we're going to have multiple feature maps. Now, just to add some kind of non-linearity, we need to include an activation layer. So we transform the values of the feature map given the function that we will use in our activation layer. I guess the most common one in this nowadays is a rectified linear unit, but just for illustration purposes, we're going to use tan in this case. So again, here X will be the specific value of the feature map, and we're going to transform this. This is how it's transformed, right? It goes from this original feature map into this one after we include the activation layer, and then we're going to collapse information or to reduce the dimensionality of the feature map while keeping the most important information using max pooling. And what max pooling is going to do is that, for example, here is going to focus on the 4 first digits, and it's going to take the largest one. So, you know, the information of these 4 digits are going to be now in this digit, and the same with the yellow one, and it's going to be, you know, all the way. Now, the outputs of the first convolutional layer are going to be the input for the second convolutional layer, which is going to repeat this, right? We can use, you know, multiple layers. In this case, we just need 2. And the outputs of the last convolutional layers are going to be the input for our neural network. So now we have this collection of different features, and the computer is going to try to guess which of these features are more likely to belong to each of our specific labels. In this case, we have 10 different outputs, right? We want to predict what number is this image, right? So the neural network is going to provide probabilities for this image to belong to each of the given categories. And it's going to learn this through a process called backpropagation. So what it's going to do is that, you know, it's going to provide a prediction, is going to compare the prediction to the true label, and then it's going to estimate the error. In this case, it's the loss. And in order to minimize the loss, it's going to go back through the network and see which of these features are producing most of the error or the loss. So then it's going to calibrate again the weights of this network, and it's going to try with a different image. So on and so forth. We're going to apply this in these cases to illustrate this using the tallies of the 2015 federal election in Mexico. Now we have 2 goals. The first one is just to extract the handwritten numbers from both tallies, but we have a substantive goal, right? Which is trying to improve citizens' perceptions on electoral integrity. The way in which vote returns are recorded in Mexico is that, you know, votes are counted in every polling station. The tally is filled there. Then the information is delivered to a specific district council. There are 300 district councils across the country. And then at the district councils, election officials are updating a system with the specific result for every polling station in a real-time system called PREP, right? Now, given the way in which the PREP works, this system tends to report first those results from polling stations closer to the district councils, right? Just because, you know, the commuting time is shorter. So those are the results that are going to come first. And given that, there are a lot of grounds for skepticism and concerns, because you can see, you can expect that the reports or the trends for each of the parties are going to change over time depending on which results are coming first and which ones are coming last, right? So we're going to try to make the process more efficient, trying to breaking this geographical pattern and actually making the report of the results faster. And this is not a problem exclusive from Mexico. Just remember what happened. Well, I don't want to mention, of course, Georgia, Pennsylvania just a few days ago, but just remember what happened in Bolivia last year, Honduras, Kenya, Haiti, Argentina a few years ago, Peru, so the list goes on. So that's kind of the main goal of our project. What we want to do first, or we need to do first, to extract the digits from the tally, which is not a trivial task. And here, my co-author or Michelle can tell you more about it. But first we need to tell the machine what part of the tally should it focus on, right? In this case, it should focus on the second page where the both results are. So from there, we tell to the tally, okay, just pick the first party logo on the tally, which in this case is going to be the pan, and then move an X number of pixels to the right, and that's when you are going to find, all the numbers, right? And then when we can start like extracting the digits, and now we can finally start predicting which of the values for each of these digits. We use an architecture pretty similar to the one I presented before. We start training the machine using the MNIST dataset, which is kind of the canonical dataset for handwritten numbers, which is super clean. All the numbers are very well centered. Is really nice. So it's good for learning. But then when we go to the real life, not all the digits are such that clean or very well aligned. So we train our machine first with this data set, and then we use transfer learning. We say like, okay, from what you learn in this, like, let's say, ideal condition, try to adapt your weights to our real data set, which in this case, we train our model with 25,000 minutes. And our accuracy rate is 97%, which is good, but it's still not the best. And we are working on ways to improve that accuracy. So this is just an example of how the model works and how it's predicting some of the numbers. And now we're on this stage about how we can. We're building this app in which now people can take a picture directly to the tally. And the app is going to extract the numbers, predict which numbers are, and then get all this information to a database which will be available to anyone. So what are our steps ahead? We are working on the tally design. So we are trying to design a tally that will make this process easier. We are also finishing the app development. We are improving the denoising process to improve the accuracy. We're also thinking on this stage in which we are not only just to delegate all the work to the computer, right? Perhaps we can have a team of humans supervising those very close cases or cases in which the computer, is not very confident about its predictions. Then we can send that information to humans. Our goal is to release this open source software, and COVID interrupt this, but we were in some talks with a few electoral administration bodies to run the first pilot test. And we want to take this opportunity to invite anyone who is interested on this project to please send us an email. We'll be more than happy to learn and collaborate with anyone interested in this project. And thank you very much.
Thank you very much, Francisco, Alejandro, Steve, and Michelle. This has been a very engaging set of presentations. And I think they very much revealed one of the key issues that that has risen in this discussion, which is to what extent we can actually integrate theoretical models with the data that exists and bring some of the tools that we use in the more technical methodological aspects of our intellectual endeavors to bear light on particular, either very specific questions in the forensics of the election, as you said, Stephen, or in the improvement of the processes of election administration. And I just wanted to make a comment, and I'll open the floor for you, the presenters, to have comments on each other's papers on what has elicited most recently. But I just wanted to make a comment on Stephen's question about the relative dearth of formal modeling in political science. I think that there's plenty. The issue is that for some, I mean, for a number of years, and even relatively recently, we have probably been unable to bring enough data to evaluate a lot of these formal models that are out there. And there is some resistance by formal modelers to do that. One of my mentors and profs, Ken Shepsley, was adamant on emphasizing theoretical development and modeling as opposed to looking at particular empirical strategies, even if he has great papers on empirical outcomes. But I think precisely because we have these methods now that are highly sophisticated, that allow us to do simulations, to incorporate uncertainty, all of the elements that you mentioned, we can probably actually start improving certain models of political outcomes, not just policy outcomes, but political outcomes, that can probably start to address many of the questions that we have more systematically. I mean, I'll just throw one out there. What kind of outcomes do presidential systems develop as opposed to parliamentary democracies? What kind of outcomes unitary states versus federalist states? I mean, typically the answers are just on one dependent variable for a limited set of years, for a limited number of cases, because there's very poor data. Well, now we have models that incorporate both more sophisticated data gathering techniques, but also more sophisticated simulation strategies to incorporate these variables at the same time, and maybe not give a very specific and precise answer, but to give us maps of possibility in terms of the sets of outcomes that are relatively more likely, and maybe that way the theory will also advance. So that's all I have to say. I will shut up and let you discuss. And then if you have questions, we have two ways of doing them. One of them is the chat, and Kristen has already mentioned something, but you can also raise your hand virtually in the participants box, and we may take questions from you. Adelante, go ahead, Stephen.
Okay, to follow up on your excellent points, because of the speed of presentation, there were a number of things that had to be jettisoned along the way. So, I mean, what you say is exactly right. Models exist. The problem is there are not the data, you know, to feed them. And we may be asking the wrong question, as I had alluded to. So that we use these models as means of being predictive, and we validate them based on outcomes or their ability to predict. And it may be that the models are just fine, but the use that we put them to is somewhat suspect. If instead of asking the question, what will happen, we instead ask the question, what would I need to believe was true in order for me to say that A will lead to B, or that a certain policy will lead to a certain outcome? Then we have the ability to do, you know, not the sort of predictive consolidative modeling, using terms developed by my former colleague, late colleague, Steve Bankus, but more exploratory modeling. That's also a legitimate use for models, but not one we tend to think of. And as the second point that you raise, the theory and the practice, indeed, that's one of the advantages that I see in kind of the approach that I have suggested, where you have a means for doing, you know, the forensic work and using that as a way to update the models, update the causal statements, not so much to enhance predictability, but to allow more sophisticated and nuanced exploration, and to derive more insightful inference from this apparatus.
Great. Michelle, Francisco, Alejandro, some preliminary comments, or should we just jump to questions from the audience?
I actually have a question for Alejandro, but it's not about, I mean, both presentations were really interesting and definitely very thought-provoking. But if you don't mind, if we can jump to questions or feedback, I think we would be also very
Why don't you get us started, Michelle? Go ahead, please.
Perfect. So Alejandro, I have a question about like how specifically, one is the clarifying question about how specifically you're incorporating the shock that COVID represented for these elections, right? Like what kind of dimensions or particular measures are incorporated in your model to detect their effect? Two, how is this COVID effect related to other dimensions as well? How are you modeling the correlation, let's say, of COVID with non-response rates in surveys? And another one that I think actually, like from an anecdotal experience, I used to work in the polling world, and from living here, and my impression is that social desirability also played a huge role. Probably lower than in 2016 when the Trump supporters were really, really shy. But this year, we are also seeing that the silent majority was still there. So how are you thinking about incorporating these things that are harder to detect with our traditional measures of measurement of survey error?
Yes, thank you so much, Michelle, for your questions. I was trying to get the primary sample units because in the online surveys we have these IP addresses, and then you can get the coordinates and try to get the information at the county level for the COVID contagion, for the COVID cases. But it's not always possible because it's difficult to get the primary sample units. So that's one option I was trying, but unsuccessfully. And the other one is in order to overcome this social desirability or the shy voters, I was trying to get in the report questions regarding to that, whether or not the questionnaire was including some question, whatever question, just at least some questions regarding or trying to reflect the concern that the poster has, right? This my concern is maybe I'm not getting the right answer, so I need to ask something else. When I see these questionnaires, there are not many questions about social desirability. So I have to figure out how to capture this idea, whether or not they are measuring this or not, and how to incorporate that. Is a perfect point and very valid, and I will take this advice. Thank you so much.
There are a couple of questions in the chat. One of them is from Kristen Cockrell. Great ideas from all. Thank you. My question is, how do we get decision makers to pay attention to this kind of work, especially at the local level? And then Antonia Hajimaikal, isn't polling responder shyness a form of input uncertainty that can be sampled and analyzed with DMDU methods? And Stephen answered something in the chat, but feel free to address it publicly, Steve or Francisco, Alejandro, Michelle, whoever wants to take these. Yeah, we can't hear you, Steve.
I'll leave it in the chat in the interest of time.
Good.
I just want to answer a little bit what we are doing. We're starting like pretty small, and we have talked with 2 electoral administration bodies in Mexico and Argentina, and the idea here is to start with a few districts with a pilot test just to check where these work, but at the same time trying to test what are the second order consequence of this, right? So whether this impact on the perceptions of electoral integrity or election trust, the number of complaints from parties or whatever, and then I guess we can scale it up to get it to a state level or a national level. But we're starting again like step by step just to make sure we are not going to screw it up.
And I think I happen to think that these are the kinds of issues in which relatively quote unquote modest efforts can go a long way in furthering leaders' ability to both understand uncertainties more in a more sophisticated way, to understand machine learning and other artificial intelligence tools at a basic level, and start gathering confidence in terms of how to be able to use them more effectively, and to provide examples that are particularly useful in terms of inviting people to understand these methods more deeply. I see no other questions, so I'll just say one more thing and then I'll ask you to close have closing remarks. One of the challenges of such sophisticated and analytically demanding methods as the ones that the Society for Decision-Making Under Deep Uncertainty has is that the entry-level barrier for people who actually want to do them is really high. But what relatively speaking, but what's very important is that we as a society understand that the framework of participation, of engagement with stakeholders makes this an incredibly productive way to address specific problems from specific policymakers in specific areas of policy. And that's our key advantage, I think. And I think at some point, everywhere in the world, there will come moments of opportunity. And that's where societies like this one are going to have to respond to them and say, hey, look, this is what we should do. Even if we don't have a specific answer, we have a framework for addressing these problems. So this is a more general perspective on it. But anyway, any point from you all, Michelle, Francisco, Alejandro, Steven, that you want to conclude with?
Nope, I learned a lot from the other presentations.
Yeah, likewise. Thank you very much. It was super insightful.
Well, with that, we close for today. Thank you all very much for being here. Papers and presentations and this recording will be available at the site of the Deep Uncertainty meeting, the 2020, on behalf of the Society and in particular of the School of Government and Public Transformation at Tecnológico de Monterrey. I thank you all very much for joining us, and in particular our paper presenters this evening, afternoon, or night, wherever you are. Thank you all very much. See you later.